Hi, everyone. Thanks for taking the time to join us on this webinar focusing on data, data transformation, and selecting the right data management system. Today, we'll discuss the process of turning data into actionable intelligence and how to select the right data tools. We'll also give a brief demo of our solution, Han Prism, at the end. Some background on our company. Hanara Software provides optimized software solutions to help the process industry improve plant management and maintenance. The purpose of our tools is to enable active monitoring and give plant personnel and management a more complete view of the plant's condition. A historian collects data and stores it into a database, typically in a time series-based format. A historian is a vital tool for the process industry to use its data, but an organization's data strategy should not stop at the implementation of a data historian. There has to be a data historian plus. What do I mean by a data historian plus, and why should you care? We're going through a technological shift where more and more data is being produced and will only increase in the coming years. Data has the potential to become actionable intelligence, but the key word is potential. Data itself does not give you information or intelligence. It requires analysis and visualizations. The ability to generate, collect, store, and access real-time and historical data is great, but then what? The process industry needs ways to analyze and visualize data and turn it into actionable intelligence. Data is also no longer siloed to a specific department or person. There is a shift towards incorporating data into all levels of the organization and all layers of the decision-making process. This doesn't mean just because you have data, you know what to do with it and how it should be used. There are serious ramifications for improper use and analysis of data, and the average member of an organization is not going to replace the data analysts and data statisticians. But we see the trend of data and data analysis seeping into all layers of the organization and process. It's no longer just the IT or key business operations domain. So data is and will continue to be important in the coming years, and all layers of the organization must understand data and the value it provides. But what does the data process look like? For Hanara, we see the data process as follows. The first step is data generation, then data collection, followed by data storage and data analysis, finally ending with actionable intelligence. This is a continuous flow, and an organization will be engaged in all of the stages at the same time. So let's take a dive into the various stages of data transformation. In any process industry, data is continuously being generated. Data allows an organization to know what is happening in the plant. Data can relate to personnel, it can relate to supply and demand, it can relate to key performance indicators. But today I'm going to focus on the data that pieces of equipment generate, more specifically, quantitative data. The first differentiation to make is quantitative versus qualitative data. Qualitative data are descriptors that cannot be described by values. For example, the manufacturer of your fan or turbine is qualitative data. In contrast, quantitative data still describes something but in numerical values. Examples include the temperature of a boiler or the speed of a belt. I've not made a value statement about which is better, quantitative versus qualitative data. It depends on the situation, the limitations, and what question you're trying to answer. For us, we focus on quantitative data, and I'm going to simplify quantitative data into two types, digital and analog. Digital data has two values, 0 or 1. You may also hear Boolean data, which is either true or false. There are only two options. In the process industry, you use this type of data for values like on or off, open or closed, high or low. Digital data is considered less accurate, but it makes up for the accuracy in that it's much easier to work with. The other type of data is analog, which has continuous values. The variation and slight changes are measured. Some typical analog types are temperature, pressure, and vibration. Analog tags are more accurate than digital tags, but they are more difficult to work with. For example, how do you know what a meaningful change is? How will you measure the variation? How much should you measure? There are going to be pros and cons to both analog and digital tags, and the process industry uses both to determine the current status of the equipment and systems. So great. The process industry generates a lot of data, but how do you collect it? Depending where you are on the digitalization spectrum, this may be automated, or you may have personnel doing the rounds to collect the data. Regardless of how it's occurring, there is one important question that you should have confidence in your answer. Can I trust the quality of the data? So what exactly is data quality? It can be described in various ways, but some items to consider are the accuracy of the data, the completeness of the data, the reliability of the data, and the relevance of the data. Is the sensor measuring the vibration properly? Are there missing gaps in measurements? Would you get the same values if you measured it again? And does the data measure what you're interested in or what is important? Being able to trust the quality of the data is key to the following steps. The next step is data storage. Data quality is important because why would you want to store garbage? If you only care about the amount of data you have, I guess it would be okay, but who cares about the amount of data stored? In the past, we've worked with customers to convert their historical data into our solution HAN Prism. Our customers asked for 5 years of data conversion, but they've been around for much longer than 5 years. So why not the full amount? Because they asked themselves, does knowing how the plant operated 10 years ago really provide us with any value? So with good data quality, you want to store the data. Real-time data is of course important, but having access to historical data is also extremely important. They say those who don't know history are doomed to repeat it, and it's the same in the process industry. But all data storage is not the same, and data storage should be optimized to meet your needs. Data storage is becoming less and less expensive, but that still doesn't mean that I should store every last piece of data collected. For us, we use a deadband method, meaning we store value changes, not all values. If for an entire day the temperature is at 40 degrees Celsius with no change, I don't need to store 40 degrees Celsius at every minute. Finally, you need to know that your data is being stored properly, but you also need to know it won't be lost or manipulated. Every organization should have a backup strategy. In addition to the backup strategy, there should also be policies and procedures about who and how data can be changed. Organizations may not care about some historical data being changed, but for compliance and regulations, some archived data should not be easily changed or manipulated. Generation, creation, and storage don't mean anything unless you do something with the data, and that comes through analysis. There are tools out there that help you visualize and analyze data. For the process industry, this may be time-based trends, comparison of related sensors, what-if scenarios, and much more. With data analysis, it goes back to the process of define your question, determine the data needed, ensure data quality, analyze data, interpret the results, and apply. Data analysis has its host of obstacles, though. The first one is correlation does not mean causation. It may indeed be an example of causation, but like innocent until proven guilty, you should always follow correlated until proven causal. The next pitfall is ignoring the context, also called naked data. Data without context is not helpful and can even be misleading. Knowing that the temperature is 540 degrees provides me with nothing. Knowing that the boiler was 575 degrees at 5:05 p.m. today and has been steadily increasing since yesterday, while pressure remains constant, is meaningful. With the context, data becomes meaningful. With thorough analysis, data can be turned into actionable intelligence. Actionable intelligence sounds like something you want to have, but what does it mean? The first side is information that you can act upon. The second side is that there should be some action taken. How should I proceed and why should I care to proceed? For Hanara, we see the benefits of actionable intelligence as improved efficiency, reduced operating costs, optimized reliability, increased availability, and increased safety. Actionable intelligence should improve the decision-making process, which in turn improves the operation of the organization overall. But like data, if actionable intelligence is siloed, not shared, or held by only a few people, it limits the effectiveness. So collaboration should be a key component of actionable intelligence. Sharing the intelligence in an effective and timely way is vital. So this sounds great, but how do you implement actionable intelligence into your process? As previously mentioned, having a historian is a great start, but don't stop there. Look for a solution that provides you with the added visualization and analysis tools that enable you to convert the historical and real-time data into actionable intelligence. But how to select the technology that's right for you? I want to talk about 6 key areas you should consider when selecting a new solution. The first is ease of access and monitoring. Data has to be accessible and easy to use 24/7. How the solution stores the data as well as the software's user experience all plays into this. If it requires 40 hours of training and is only accessible on 2 computers in a specific office, it's time to look elsewhere. The second is centralized integration and collection. Equipment and systems do not exist in a vacuum. They interact and impact each other. Having data siloed by equipment creates unnecessary obstacles and ineffectiveness. A solution should be able to serve as a central location for all your data needs. Similarly, the third consideration is historical and real-time data access. Both are important, and you should check the speed of retrieving historical and real-time data. No one will use a solution if it takes 10 minutes to create a 1-month historical trend of a single tag. The fourth item is built-in visualization and analysis tools. Again, you shouldn't need a PhD in computer programming or statistics to use data in the decision-making process. Having a Historian Plus with robust visualization and analysis tools will improve the process entirely. The fifth item is dashboard capability. We've been hearing a lot from our customers about the importance of dashboards. Plants want a way to visualize their important sensors and constantly monitor it. The sixth and not to be forgotten consideration is data security. For Hanara, our solution Han Prism is only for monitoring. There is zero controlling, and it was designed to be that way. For us, we use a solution called Han Direction that physically prevents any commands or information going back into the system. Whatever system you choose, make sure it meets your security requirements. We believe our solution Han Prism helps customers overcome their current data obstacles and achieve operational excellence. So how does Han Prism work? The first stage is collecting the data. Han Prism can collect from various data sources, including the DCS, SCADA, and PLC. From there, the Han Prism server archives the data and makes it accessible to other applications and provides ERP integration. On the client side, Han Prism enables the user to do real-time monitoring of the plant, search for data and information, analyze data, and create reports for better decision-making. Based on your needs, the client can utilize Han Prism as a plant information system, data historian, plant infrastructure, or enterprise data infrastructure. On the client side, there are various visualization and built-in features, including trend charts, reporting tools, process graphics, and alarms. These are some eye charts, but let's move to an actual demo of the solution. So why does a plant need Han Prism? For effective operation and improved plant availability. For effective operation, a plant monitors data in real time and historically for quicker analysis. A plant can share identical information throughout the plant for better communication, and plant personnel can care for the plant anytime and from anywhere. This improved monitoring, analysis, and collaboration helps the plant achieve operation excellence and reduce unneeded costs. That wraps up our webinar today. If you have any questions or would like a more in-depth demo, feel free to reach out.